Hello friends, good evening to everyone. Okay, so today we will discuss some more interview questions for data science interview. Okay, so let's start with our first question. So today's first question is, what is cross validation? What is cross validation? Okay, try to answer this question in your way. What is cross validation? What I will give you some time. Try to answer this question. Okay, so cross validation is a statistical technique used for improve the model's performance. Okay, here the model will be trained and test with the rotation using different samples of the training data set. Did you understand? Means in a cross validation, we will run our model on different test data sets. Okay, to ensure that our model is performing well for unknown data sets as well. And how to take the different test data set? The training data will be split into various groups, and the models is run and validate against this group of rotations. Is it clear? Means cross validation, it is the technique where we have our data. Okay, so in that what we do, we take different test sample for those data, and then we will run our model on those. Okay, and we are going to check the accuracy of our model, right? Is it how it is performing for different test data sets, right? So cross validation is technique using to improve our model's performance, right? Means every time you are giving the new data set, new test data to cross validation to the model in a cross validation, and checking the accuracy of our model for each of the test data, how it is working. Okay, so there are various ways, and the most common techniques are used for cross validation is like k-fold method, leave p out method, leave one out method, hold out method. Okay, these are some of the most common techniques are using for a cross validation. Okay, so I just now again repeated what is cross validation. Okay, so see, cross validation, it is a statistical technique using for improving the model performance, right? The model will be trained and tested with the rotating using different samples of the training data set, right? To ensure that our model will performing well, right? Okay. So how to divide the data set means where we are getting the test data set, different test data set. The training data will be split into various group, right? And we are considering it as a test data and running our model on that. And every time we are just checking accuracy of our model. What was the accuracy of our model for each test data, right? This is the cross validation technique. And some more some of the common techniques of cross validation is like k-fold method, leave p out method, leave one out method, hold out method. These are the methods we are using for cross validation. Okay, is it clear? Okay, now today's next question is, what are the difference between correlation and covariance. What are the difference between correlation and covariance? Okay, try to answer these questions. Firstly, try to understand what is correlation and covariance. Then you are able to define the difference between both. Try to give answer in chat window. Okay. So the difference between correlation and covariance is like, okay, firstly, both the terms are using to find out the relationship between two variables, right? Both the terms are using for finding out the relationship between two variable or the dependency of a variable, right? So firstly, we understand the correlation, right? This is the technique is used to measure and estimate the quantitative relationship between two variables and measure in terms of how strong these are, right? Mean when we are talking about the correlation, okay, it is telling us how the relationship of one variable with other, right? Is that a positive relationship or a negative relationship, right? And how strong this relationship are, right? The range of correlation is from -1 to +1. Okay, means whenever the changes happen in one variable, okay, it's the positive changes happen in one variable, then again the second means the variable is correlated with that, is there changes happen in that variable as well in a positive manner, that is the positive correlation. Okay, and if the changes happen in one variable in a positive manner but the changes of the related variable happen in a negative manner, so that is the negative correlation. But the range from that is like -1 to +1, right? -1 is strong negative correlation, right? Strong negative correlation we have between two variables, right? And +1 means strong positive correlation between a two variable. Okay, this is the correlation. So what is the covariance? Okay, so if we consider a covariance, it is also telling us the relationship of two variables, right? But it will not tell you how strong this correlation, how strong this relation are, right? Means it is just showing you whatever the impact of first variable, what is the impact of that on a second variable, right? Here also we have positive correlation and negative correlation. Means if we have positive difference in first variable, then then the changes in a related variable is also positive, right? That is the positive correlation, right? But if we are having positive changes in first variable and negative changes in a related variable, that means the negative covariance, negative correlation, right? But the difference between, what is the difference between correlation and covariance, did you understand? In a correlation, it is telling us the strength of the relationship, right? What is the strength of that relationship? Because there we have range. The correlation is between -1 to plus 1, right? In covariance, it is just giving us the direction. Okay, this is the positive correlation, this is the negative correlation. It is not giving us the strength of our relationship, right? Strength of the two variables relationship, right? So these are the difference between correlations and covariance. Is it clear for you? See, the use of both are same. Both are using to find out the relationship, right? Between two variable, right? But the difference is clear. In correlation, we can find out the strength of the relationship. And in the covariance, it is just telling us that direction, like is it a positive correlation or a negative correlation? But how strong is that relationship? Covariance will not able to tell us, right? For that, we will use the correlation to find out strength of the relationship. Is it clear? Okay. Now, next question. Why do we need selection bias? Or what is the selection bias? You can consider anyone. Why do we need selection bias? Okay, try to answer this question in a chat window. Okay. So selection bias happen in case where there is no randomization specially achieved while picking the part of the data set for an analysis, right? This is the bias that tells the sample analyzed does not represent the whole population mean to be analyzed. Okay, I will tell in a simple manner. Selection bias is nothing but it will appear when we are taking the sample data for analysis, right? So if whenever we are taking, if the data, if there is no randomization in that data, right? So that is the selection bias, right? That selection bias is telling us that whatever sample we have taken, okay, it is does not representing the whole population mean to be analyzed, right? This help us to question whether we have selected the right data for analysis or not, right? Means whenever we are taking sample, what is our actual scenario? Our actual scenario is like when our data size is huge, the population data is huge, we will perform some calculation on a sample data and make a statement about the population mean, right? But when we are selecting our sample, the sample is not random. Okay, the data is not randomized. There is some pattern when we are selecting the sample, right? Or it is not representing the population, right? So we can't make the statement of population. That was the wrong thing, right? Because we can't have, we don't have the actual sample of the population, right? Our population is different and sample is telling some different, right? So that's the reason we are needing the selection bias. This is helping us to finding out, to question whether we have selected a right data for analysis or not, right? Every time we need the data is random, right? Or the sample that is randomized. If that is not randomized, whatever the statement we are going to make, that will not fulfill the requirement of the population data, right? So that selection bias is helping us to finding out whether the selected data is right for analysis or not, right? Is it clear? Why do we need the selection bias? See, the selection bias is just tells that the sample analyzed does not represent a whole population mean that to be analyzed, right? Our aim is like whatever sample we are taking, it have to represent the population, right? So in that manner, selection bias is helping us, right? Is it representing the population or not, right? So that data is relevant to analyzed or not, right? If that is not representing the population, there is no need to perform the analysis on that data, right? Is it clear now? Why do we need the selection bias? Let me know in the chat window. Okay. Now I will go with the another question. Today's next question. The question is like, will treat the categorical variable as continuous variable result in a better predictive model? Okay, I will write down the question for understanding purpose. Then you will try to answer this question. Just give me yes or no, right? If yes, what is the reason, right? If no, what is the reason? Okay. Yeah, I will write down question first. Will treating categorical variables as continuous, as continuous variable result in better predictive model. Okay, understood the question? Will treating categorical variable as continuous variable result in bettering predictive model? Try to answer this question yes or no. If yes, what is the reason? If no, then also give me the reason. Okay. Okay. If you ask me, I said yes. Okay. Because a categorical variable is a variable that can be assigned two or more than two categories with no definite category ordering. Okay. Firstly, what we have to understand, a categorical variable is a variable that can be assigned two or more than two categories with no definite categorical ordering, right? That means that in that categorical variable, we don't have any order, right? Categorical variable will divide in the two steps, right? One with the order. There we have order of the categorical data, and one there we don't have order of the data, right? So order of the data, that means, see, we can consider an example of our schools, right? Firstly KG, then nursery, then school, then high school, then graduation, right? Then post graduation, PhD, right? This is the order, right? This is the order for a categorical data, and some of just a random states, random labels, right? There is no order for those data. Okay, so the ordinal variable are similar to the categorical variable with proper and clean ordering definitions. Okay, so if the variable is order, then treating the categorical values as a continuous variable will result in better predictive, right? Means if you ask me, will treating categorical variable as continuous variable can be the give us the better predictive model, better prediction? Yes, but in a way, when we have categorical data in a order form, right? When we have ordinal data, then we can convert it, and if we apply a model and we predict, yes, we can get a better accuracy. Okay, so you understood? Yes, we can treat that as a continuous data, but if we have a categorical data in order form, yes, it will give us the better result, right? For prediction. Okay. Is it clear? Okay. So now we go with the next question. So today's next question is, what does the ROC curve represent and how to create it? Or firstly, we will just see what does the ROC curve represent and how. Okay, just a little bit. Okay, we know that there is the library that we have to call and everything. Okay, what does the ROC curve represent? Firstly, we understood this. Okay, try to give this question's answer. Okay, if you ask me in a theoretical manner how to create it, yeah, then I'll add create it. Yeah. Give me response in the chat window. What is the ROC curve? Okay, so ROC curve is a graphical representation of the contrast between false positive rate and true positive rate at a different threshold, right? ROC curve is a graphical representation of contrast between false positive rate and true positive rate at a different threshold. Threshold will be different, okay? It will depend on the scenario, okay? Whatever the threshold you are going to select, okay? The curve is used as a proxy to handle trade-off between sensitivity and specificity. So did you understood what does the ROC curve? ROC curve is nothing but it is the representation of true positive rate and false positive rate at a different threshold. Okay, now how to create it? The ROC curve is created by plotting values of true positive rate against the false positive rate, right? True positive rate means sensitivity against the false positive rate, that means 1 minus sensitivity, 1 minus specificity, okay? Means whenever we are plotting ROC curve, on x hand side we have true positive rate. True positive rate means sensitivity, and the y-axis, the x-axis we have specificity, that means 1 minus specificity, and on the y-axis we have sensitivity, that means true positive rate on y-axis and false positive rate on a x-axis. Okay, true positive rate representing the proportion of observation correctly predicted at positive out of all overall positive observation, right? That means on y-axis what it is showing the true positive rate. The true positive rate is the representation of proportion of observation that are correctly predicted as positive out of overall all positive observation, right? And on the y-axis, on the x-axis, we are having false positive rate, that is representing the proportion of the observations incorrectly predicted out of all negative observations. Okay. Did you understood how to plot ROC curve? ROC curve is nothing but it is the representation of false positive rate and true positive rate at a different threshold. Okay, so true positive rate, that means the observation are correctly predicted as positive out of overall all positive observation, right? False positive, that means the proportion of observation is incorrectly predicted out of overall all negative observation. Okay, this is the ROC curve. Okay, this is in this manner we will plot the ROC curve, right? So the area above the curve, larger area above the curve, that will be better for us, right? So we want always the area above the curve is high. Okay, now next question is it good to do dimensionality reduction before fitting a SVM model or support vector machine model? Is it good to do dimensionality reduction before fitting a SVM model. Okay, try to answer this question. Is it good to do dimensionality reduction before fitting a SVM support vector machine? Okay. See, in which scenario it is good, we will see that if the features, if the number of feature, sorry, if the feature number is greater than the observations, then doing the dimensionality reduction improves the SVM. Did you understood? If the feature numbers, features means the columns, right? This columns are, the number of column are huge, right? So if we do that time a dimension reduction for SVM, it will good, because if we use directly that data, it will consume more time, right? It will take a computational time is too high, right? And if we apply model on that data, right, if we apply, if we don't remove, don't do the dimensionality reduction, if we apply model and that data, it will take time, right? So what does the dimensionality reduction just do? It will just minimize the number of column with the same amount of information that we are having, right? And like that is the PCA. PCA is one of the example for dimensionality reduction, right? If we apply that, yeah, our model will give us the better accuracy and also with the less computational time. So if the features, if the feature number is greater than the observation means rows, sometimes it will happen, right? In real world, rows are less and columns are huge, right? So if the feature number is greater than the observation, then doing dimensionality reduction improves the SVM, improves the support vector machine learning model, right? Is it clear now? Okay. Next question is, what is the importance of dimensionality reduction? Okay, now just now we have seen, is it good for SVM or not? Okay, so if I ask you the importance for that dimensionality reduction, I am expecting some answer from you in the chat window. Till then, I will write down the question. What is the importance of dimensionality reduction? Okay. Try to answer this question. Okay, so firstly, we will understand what is the dimensionality reduction. Okay, and then okay, the process of dimensionality reduction consisting reducing the number of features in a data set, right? That means when we have huge data, when we have more number of column, dimensionality reduction, when we apply dimensionality reduction on that, it will just try to minimize the number of column with the same information, right? To avoid overfitting and reduce the variance. Okay. There are mostly four advantages for this process. We will see that. Okay. So first, did you understood what is the dimensionality for first? Dimensionality reduction, that means when we have huge data, when we have more number of variables, okay, it will just minimize the number of variable to avoid overfitting of our model and reduce the variance, right? So now we are going to see some of the advantages for that. Firstly, this reduce the storage space and time consuming for the model execution, right? If because it is just minimizing the size of our data, so the time required for model execution will goes down, right? And it will also reduce the storage space, right? The next advantage is it will remove the issues for multi-collinearity, right? Thereby improving the parameter interpretation of the ML model, right? It is also solving the issue of multi-collinearity, right? The next one is like, it makes it easier for visualize the data when dimension are reduced, right? If we plot any plot for the huge dimension, huge featured data, okay, huge data, the plot is like little, means the size of plot is not that much great, okay, we can't see anything, we can't predict anything from that plot, right? So if we apply dimensionality reduction, it will make easier to visualize the data, right, by reducing the dimension. Last advantage is like avoid the cause of increased dimensionality, right? So there are four advantages. Firstly, it will reduce the storage space and time consuming. Next, it will reduce the issue of multi-collinearity. Third one is like it is make easy to visualize after reducing the dimension. And fourth one is avoid the cause of increased dimensionality. Okay, is it clear for you what is dimensionality reduction and what was the importance for those? Is it clear now? Okay, so I will write down the next question. Try to answer that question. The question is, what are some of the technique used for sampling and what is the main advantages of sampling? What are some of the techniques used for sampling and what is the main advantage of sampling. Okay, try to answer this question. Just try to tell me what are the sampling technique, what are the types of sampling technique. Okay, that will be enough. Other than that, I will explain. Okay, so firstly, we understand what is the main advantage of the sampling. Okay, that see, data analysis cannot be done on a whole volume data, right? At a time, especially when we have large data set, it becomes crucial to take some sample of the data that is representing the population and then perform analysis on that, right? But it is very much necessary to carefully take a sample out of huge data that is truly representing the population, right? So the advantage of sampling is, right, whenever we have huge data, if we take sample and we do whenever we have huge data, we can't do calculation on that data, right? So in that scenario, we will take sample and perform some analysis on that and make a statement about the population, right? That is the main advantage of the sampling, right? So there are some of the techniques for sampling. The two main techniques of sampling is, right, probability sampling techniques and non-probability sampling technique. Okay, now you're going to confuse. Okay, these are, we are not hearing like these are the probability and non-probability. Okay, so in a probability sampling technique, we can consider cluster sampling, simple random sampling, and stratified sampling. Okay, and in a non-probability sampling techniques are quota sampling, convenience sampling, snowball sampling. Is it clear? The advantage of sampling is, right, when we are doing the data analysis, we cannot down on whole data set, right? That time we have to take a sample size that is representing the population. On that we will perform some analysis and we will conclude, okay, something like this is the population data. This is the statement about the population data, right? There are two main types for the sampling. First type is probability sampling technique. Next one is the non-probability sampling technique, right? So the probability sampling technique consisting cluster sampling, simple random sampling, and a stratified sampling. Okay. And in a non-probability sampling technique, that is the quota sampling, convenience sampling, and snowball sampling. Okay. Is it clear now? What are the some types and techniques using for sampling, right? And the advantages of that. Okay. The techniques are, if you ask me, the techniques for the sampling, that is the probability sampling technique and non-probability sampling technique. In a probability sampling technique, we will consider as clustered sampling, simple random sampling, and stratified sampling. In non-probability sampling, first is quota sampling, next is convenience sampling, last one is snowball sampling. These are the sampling technique, probability sampling and non-probability sampling, and these are the subtypes of that sampling. Okay, is it clear now? Okay. Now the most important question is coming, and I'm expecting answer from you. What are the eigenvectors and eigenvalues? What are eigenvector and eigenvalues? Okay. What are the eigenvector and eigenvalues? What are the eigenvector and eigenvalues? Okay. Firstly, we go with the eigenvector. Eigenvector are the column vector or unit vector, okay, whose length or magnitude is equal to 1. They are also called as a right vector. Firstly, what is the eigenvector? Eigenvector are a column vector or a unit vector whose length or the magnitude is equal to 1. They are also called as a right vector. Okay. Then what is the eigenvalues? Eigenvalues are the coefficient that are applied on a eigenvectors. Right? Eigenvalues are the coefficient that are applied on a eigenvector, which gives this vector different values for the length or magnitude. Right? Okay. Again, eigenvector are a column vector or a unit vector whose length or magnitude is equal to 1. Eigenvalues are coefficient that are applied on eigenvectors, okay, which gives these vectors different values for the length or a magnitude. Okay. See, a matrix can be decomposed into eigenvector and eigenvalues, right? And this process is called as the eigen decomposition. Okay. Eventually, this process is used in a PCA for gathering valuable insight from our given matrix. Did you understood what is the eigenvector and what is the eigenvalues, and when we are using? See, eigenvector and eigenvalue. Eigenvector is nothing but a column vector or a unit vector. We can consider it as a column vector, and whose length is equal to 1, right? And eigenvalues are the coefficient that are applied on eigenvectors, which gives these vectors different values for the length or a magnitude. Okay. When we are decomposing any matrix into eigenvector and eigenvalue, these are called as the eigen decomposition, right? We can use eventually this process in a PCA, right, for gathering valuable insight from the given matrix. Okay. So this is the eigenvector and eigenvalue. Now, next question. What is resampling done? What is resampling done? Oh, sorry. Yeah, try to answer this question. What is resampling done? Okay, so resampling, it is the methodology used to sample data for improving the accuracy of our model, right? It is done to ensure the model is good enough by training the model on the different patterns of the data set, right? To ensure it is handling variation, right? It is done in case where the model need to validate using random subset, or when the situating label on the data points while performing the test. See, resampling is nothing but it is the methodology. It is used to sample data. It is used to sample the data for improving the model accuracy and quantify the uncertainty of the population parameter, right? It is done to ensure our model's quality. If we apply, right, it is done to ensure that the model is good enough by training the model on the different parameter of the data set, right? To ensure that our model is handling the variation, right? It is done in case where the model needs to validate using random subset, right? Did you understood? When is resampling done and what is that? Resampling is a methodology. Resampling is used to sample the data for improving the model's accuracy, right? It is doing resampling we are doing to ensure our model is good enough for the different pattern, right? And it is handling variations. If we are providing variation in data set, it is giving us the good accuracy to ensure that we will done the resampling, right? It is also done in case where the model needs to validate using the random subset. Okay, is it clear for you what is the resampling then? Okay, so these are the questions for today, friends. Okay, so we will meet tomorrow again. Till then, bye bye. Have a good day.